is nothing but electromagnetic waves and transmission lines. Before going to discuss about the electromagnetic waves and transmission lines, first of all we should know the difference between the circuit theory and the field theory. So what is circuit theory? The circuit theory is only applicable for the portion of the radio frequency range. The parameters which are to be used in the circuit theory are voltage and current. It is a two-dimensional analysis and lumped components which are to be used here. There we are using for analyzing this circuit theory, we are using the Laplace transforms z, y, h parameters which are to be used. What is a field theory? The field theory which is to be not applicable for the portion of the radio frequency range. It is directly obtained from the electric field and the magnetic field, which are to be designated as E and H. The parameters like permittivity and the permeability, which are to be analyzed in the medium, and the Maxwell's equations, which are to be used for analyzing this field theory. It is a three-dimensional analysis, and the distributed parameters are the distributed components which are to be used in the field theory. So, before going to start about the electromagnetic waves and transmission lines, we should recall about the vector analysis. What is the need of vector analysis for learning about the EMWTL? As we know that EMWTL is nothing but electromagnetic waves and transmission line. That means electromagnetics is the branch of physical, or otherwise it is the branch of physics or an electrical engineering where we are using or where we are studying about the electric and magnetic fields. So before going to know about the EM waves or electromagnetics, we should be able to, or we are capable of knowledge in the vector analysis. It is the prerequisite for the study of the electromagnetic field theory. So before that, what is a scalar quantity and a vector quantity? As we are already know that a scalar quantity which has only the magnitude. For example, mass, time, distance, these are all to be some of the examples of scalar quantities. A vector quantity which has both the magnitude and direction. Force, velocity, displacement, electric field intensity, these are all to be the examples for the vector quantities. What is a field? The electromagnetic theory is essential of studying about the certain fields. Field is nothing but a point of region, and fields may be classified as a scalar fields and a vector fields. A scalar field. What is a scalar field? A physical function at each point is a scalar quantity. The field is known as the scalar field. For example, temperature distribution in a building or sound intensity in a theater, height of the surface of the earth. These are all some of the examples for scalar fields. Scalar field is an independent of time called as a stationary or a steady state scalar field. Vector field. A physical function at each point in a is a vector quantity is a that field is known as a vector field. For example, gravitational force on a body in space, velocity in the atmosphere, force on a charged body placed in an electric field. These are some of the examples. And this vector field is a time independent. That's why it a time independent vector is called as a stationary vector field. What are the properties of vectors? Vectors can exist at any point in the space, and vectors have both the direction and magnitude, and the two vectors that have the same direction and magnitude both are equal, and no matter in the space which are to be located, that is called as a vector equality. Unit vector, it is a very important definition. A unit vector a bar has both the magnitude and direction. The magnitude of a bar is a scalar written as a or mod of a bar. And components of vectors. What is a component of a vector? A Cartesian coordinates may be represented in ax, ay, and az, which are to be represented as a bar is equal to ax plus ay plus az. Here the capital ax, ay, az are called as the component vectors and in the xyz directions respectively. And vector decomposition. Choosing a coordinate system with the coordinates and axes, we can decompose any vector in a component. Let's see the example where here it is nothing but the x direction, it is nothing but the y direction, and it is nothing but the z direction, and the unit vectors which are to be moving towards the x y z direction, they are ax, ay, and az, and direction angles and direction cosines of a vector. The direction cosines of a vector are merely the cosines of the angles that vectors makes with the x, y, z axis. We label that angles as alpha, beta, and gamma with respect to the represented axis like x, y, z axis. And vector algebra. These are some of the important properties regarding the vectors. Commutative property. What is commutative property? The order of adding vectors does not matter. A bar plus b bar is equal to b bar plus a bar. This is the commutative law. And associative law. When adding three vectors, it does not matter with that. A bar plus of b bar plus c bar is equal to a bar plus b bar of plus c bar. And identity element of a vector addition. There is an unique vector 0 that acts as an identity element for the vector addition. A bar plus 0 bar is equal to 0 bar plus a bar, that is equal to a bar. Inverse element of for vector addition. Minus a bar is equal to minus 1 of a bar is equal to minus of a bar. That means a bar plus of minus a bar is nothing but the 0, which is nothing but the unique inverse vector for every vector of a bar. This means that a vector minus a bar has the same magnitude as a bar, but in the opposite direction. That's why a bar is equal to mod of minus a bar, that is equal to a. Distributive law of addition. Vector addition satisfies the distributive law for the multiplication by a number. Let C is a real number. C of a bar plus b bar is equal to C a bar plus C b bar. On vector multiplication product, there are two types called scalar product or otherwise called as a dot product, and vector product otherwise called as a cross product. When two vectors a bar and b bar are to be multiplied, the result may be either scalar or a vector depending on how they are to be multiplied. Suppose for example scalar product or a dot product. A bar dot b bar is equal to ab cos theta. Theta ab is the small angle between a bar and b bar. A is equal to mod a bar and b is equal to mod b bar. With respect to that, the properties of dot product a bar dot b bar is equal to b bar dot a bar, it is nothing but the dot product is a commutative. And the second property C of a bar dot b bar is equal to C a bar dot b bar. It is nothing but here the C is nothing but the scalar. The second property which involves that the dot product between a vector C a bar and the vector with b bar. The third property, the dot product between the sum of vectors a bar and b bar with a vector c bar. A bar plus b bar or dot c bar is equal to a bar dot c bar plus b bar dot c bar. This shows that the dot product is a distributive and the dot product is a commutative. Similarly, the relations are given like this: a bar dot cb bar is equal to c of a bar dot b bar, or c bar of a bar plus b bar is equal to c bar dot a bar plus c bar dot b bar. And vector decomposition of a dot product. Now we develop